If you're building anything with AI right now, you know it's an amazing time. But well, is it also confusing? It feels like a new model drops every single week, and every single one of them claims to be the new king of the hill. So today, we're going to cut right through all that noise. This is your guide for making one of the most critical decisions you can make, choosing the right LLM. Ah, this is it, right? The question that keeps every single developer up at night. The leaderboards are just this constantly shifting battlefield of benchmarks. But you know what? Chasing that top spot? It's a trap. The real question we should be asking isn't which model is the best. It's which model is the best for my specific problem. And that really brings us to the core idea of this whole explainer. I mean, this quote just nails it. In a production environment where real users are waiting and real money is on the line, the biggest, most powerful model is very often the wrong choice. So our goal today is to completely shift our thinking. We're not trying to find the best model, we're trying to find the right one for the job. Okay, so let's start by totally reframing the problem. This is not just about picking a tool out of a toolbox. No. This is a fundamental architectural decision. It's a business decision that's going to impact your product's performance, its cost, and ultimately your user's entire experience. It's really a constant balancing act. You're juggling these four critical factors. You've got accuracy, latency, cost, and reliability. If you push for maximum accuracy with some giant model, you'll probably kill your latency. And if you try to slash costs with a tiny little model, well, its reliability might go right out the window. The sweet spot is always somewhere in the middle, and finding it, that's the real art of AI engineering. So, to make this balancing act a little bit easier, let's simplify things. Seriously, instead of trying to compare dozens and dozens of individual models, we can just group them into this really powerful framework of 3 simple tiers. Trust me, this approach is going to make your decision-making so much clearer. All right, check this out. At the very top, you've got Tier 1. These are your frontier models, right? Your GPT-4os, your Claude 3.5 opuses. These are the heavy thinkers, absolutely perfect for really complex, multi-step reasoning. But, and this is a big but, they're slow and they are expensive. Then in the middle you have Tier 2. These are the workhorses. They're all about balancing cost and capability. This makes them perfect for common tasks like RAG or summarization. And finally, you've got Tier 3, the small models. These things are lightning fast, super cheap, and ideal for simple classification or tasks that need to run right on a device. So here is the crucial insight, the one thing to take away. You would not use a Formula One race car to go to the grocery store. Right? It's complete overkill, it's insanely expensive, and it's just impractical. Well, the exact same logic applies here. Just classifying some simple user intent does not require a massive Tier 1 model. Using one is literally just burning money for no real user benefit. The key is always to match the tier to the task. And this idea leads us directly to a core economic principle that every single AI engineer needs to understand: the law of diminishing returns. It's right here where that gap between the so-called best model and the truly right model becomes crystal clear. So what does this mean for LLMs? Well, diminishing returns is that point where each step up in model size gives you a smaller and smaller boost in quality, while the penalties, the cost and the latency, they get bigger and bigger. You end up paying this huge premium for a tiny and honestly often unnoticeable improvement. And this chart just illustrates the point perfectly. Take a look. To get that, say, 20% bump in performance by jumping from a Tier 2 to a Tier 1 model, you might be facing a 90% or even higher increase in your costs. For most applications out there, that trade-off is it's a bad deal. It doesn't make any sense. That's money that you could be spending on other features or, just keeping as profit. And here's the secret weapon, the thing that changes the whole game: great engineering. A well-prompted, well-grounded Tier 2 model can often run circles around a carelessly used Tier 1 model. By doing things like providing better context with RAG or enforcing structured outputs like reliable JSON, you can get way better results from a cheaper, faster model. So if engineering is the answer, what does that actually look like in practice? Let's talk about the specific technical levers you can pull to really dial in your performance and your cost. This is where your skill as an engineer allows you to get the absolute most out of any model you choose. First up is latency, but we have to break it down into 2 parts. The first is time to first token, or TTFT. This is all about perceived speed. It's that moment when a user sees the chatbot start to type. A low TTFT makes an application feel responsive, it feels alive, even if the full answer takes another second or two. It is a huge factor in user experience. And the second part is tokens per second, or TPS. This is the streaming speed. Once the model actually starts talking, how fast do the words appear on the screen? A high TPS creates the smooth, natural flow, but a low TPS just feels sluggish and broken. You really have to optimize for both TFTT and TPS to get it right. Okay, now let's talk about money. You have to know this. Not all tokens are created equal. Input tokens, so the prompts you send to the model, are actually pretty cheap. The model just has to read them. But output tokens, the stuff the model writes back, are way more expensive. And why? Well, it's because generating each and every one of those tokens requires a full computational pass through the entire network. This cost difference is a critical factor you have to design around. So how do you control these costs? Well, you have to manage your token budget like a hawk. This means you enforce hard limits on your output length. You use effective stop sequences so the model doesn't just ramble on forever. You find clever ways to compress your prompts, and you truncate long contexts. Every single token you save is real money back in your pocket. So far, we've mostly talked about how to choose a single model, but the most sophisticated production-grade systems, they're moving way beyond that. The future isn't about finding one perfect model that does everything. It's about making multiple models work together in a really smart system. A good way to think about it is it's less like hiring one single genius and more like building a highly effective team where you have different specialists for different tasks. This approach is called orchestration, and it is quickly becoming the gold standard for building robust, scalable, and cost-effective AI applications. A perfect example of this is something called a router architecture. It's so elegant and it's incredibly effective. So when a query comes in, you don't just immediately send it to your big, expensive model. No. First, a tiny, cheap classification model, a Tier 3 model, takes a quick look. It just asks, is this question simple or is it hard? If it's simple, it gets routed to a fast, cheap Tier 2 model, and only the truly complex queries get escalated up to that expensive Tier 1 model. It's really the best of all worlds. It's fast and cheap for most tasks, but you still have all that power when you really need it. And if you take this idea just one step further, the ultimate strategic goal is to build a system that is completely model-agnostic. What does that mean? It means your application's core logic isn't hard-coded to, say, GPT-4o or Claude 3.5 Opus. Instead, you treat the model itself as a swappable component. The benefits of doing this are just enormous. Think about it. When a new, better, cheaper model version comes out, you can swap it in with zero friction. If your main provider has an outage, you can mitigate that risk by just switching to a backup. This kind of design decouples you from the chaos of the model market, and it gives you the ultimate flexibility to optimize your costs and to control your own product's destiny. So let's end on this thought. I think we're all kind of waiting for the next supermodel that can do absolutely everything. But maybe that's the wrong way to look at the problem. Maybe the future of AI engineering isn't about finding that one solo genius, but instead, it's about becoming the conductor of a smart symphony of many specialized models, each one playing its own part perfectly.